Well, we're back here at the Cave of Science, and today we're going to review, the test from the other day. Again, many of you are still not putting your answers in complete sentences, so you gotta make sure you do that. And there's the formula for density was given. Density equals mass divided by volume. All right, question number one. What are the percentages for point 12? Use the diagram below. As we talked about in class, we know that limestone increases from 0 to 100 at the apex here. So there's limestone. And then we go counterclockwise. So sandstone goes from 0 to 100. And then shale on the left-hand side from 0 to 100. So we're looking at point number 12 here, which is this point right here. So let's do our limestone. So limestone, we go from 0 to 100. And we see it is at 30. Sandstone, we're going up, goes across, is at 60. And then shale, as we go down, is 10. And again, we did many of these in class, so hopefully you got that. And we want to look at point number 13. So as we're looking at this one, and again, it's the same procedure. Limestone increases from 0 to 100% limestone. Sandstone from 0 to 100% sandstone. And then shale from 0 to 100% shale. So we're looking at point number, I believe it was the point number 13. So as we move from left to right along the bottom, we see that limestone is 10%. And as we move up on the right-hand side, sandstone is 30. And then as we move down on the left-hand side, we see that shale is 60. There's a point. Remember, the built-in check is all the percentages should equal 100. So that third check, especially on the left-hand side, should give you 100%. And again, that we talked about that being the built-in check for that. Is ice a mineral? If so, what characteristics must be exhibited? Well, we talked about this in class and also from the lecture. Ice is a mineral because it is solid, it's inorganic, it's naturally occurring, it's not man-made, has a definite chemical composition, and it has a crystal structure and a particular atomic arrangement. And water is H2O. And so those are the characteristics of a mineral. If we were to identify a mineral, we could use hardness, we could use a cleavage, we could use fracture, we could use color, though that's not very reliable. We could use specific gravity, which is really the density. And we could use taste, we could use texture, we could use luster if we wanted to identify. But here we want to know the characteristics of a mineral. Question 4 was pretty much a straight just XY graph. It says using the graph above, what's the name of the mineral that forms at a temperature of 1400 degrees and a pressure of 60 GPa, which is it's a Pascal. It's a unit of pressure. So pressure here is 60. And if we go up here at 60 and 1400, we see it falls in the cosite, and that is the correct answer. And it's our typical XY graph. And you also did a couple of these in class before. Question number 5, you find a light-colored rock. Well, if you know it's light-colored, it's going to be felsic. If it was dark-colored, it would be mafic. If it's light-colored, what is the probable mineral group? Well, the largest, most abundant mineral group in the earth is the silicates. That was the name of your packet. And if we look at silicates, we know they are composed of silicon and oxygen. By far the two most abundant elements in the Earth's crust. So, when it says probable mineral group and what elements are in this rock, you can't go wrong by saying the silicates and silicon and oxygen. They are the most abundant. Number 6, we just did a straight classification. And when we look at this, the first one, I'm going to go back and forth a little bit. Coarse grained rock with rounded fragments. This was actually the last lecture you did. And coarse grain, right in here, it says coarse, rounded fragments, and that rock is conglomerate. If it was coarse and angular fragments, it would be breccia. And this is straight up, table interpretation here. Near Surprise Lake at the end of the Lupine Trail and Teton Mountains, you see a rock that shows layering. Layering, banding might have been a better term here. We talked about layering and banding, and right away we saw the layering when you did your rock identification. That was a metamorphic rock. The other giveaway here is the small crystal size. Remember, metamorphic rocks under heat and pressure. And so, what is the probable rock type? It's metamorphic. How is it formed? Under heat and pressure. And what term is used to describe layering? And that is foliation. Question number 8, we're looking again at the data table here, the chart. It says, what type of rock is formed of very fine crystalline quartz? Well, if you look around here, very fine crystalline quartz, and it's chert or flint. And again, that was pretty much just deciphering a data table there. And again, put these in complete sentences. The rock that is formed is chert or it's flint. It doesn't take much to put in a complete sentence. This was the diagram for the rock cycle that you have. If we're going to start at the top here, we know magma, as it cools, it will form an igneous rock. Igneous rock, if it weathers an erosion, you get some sediment, and that sediment can deposition, and then compaction and cementation will form a sedimentary rock. And if that sedimentary rock goes under heat and pressure, that is metamorphic. And if that metamorphic rock melts, it can form magma. And you can cut across in all different directions here. This was the last lecture you have, and this was also the table you had in your packet. So we want cycle of the rock cycle in labeled I. And so it's melting. Metamorphic rock that melts will form magma. And magma that cools will form igneous rock. And let's go on down to the next one, which is really the same cycle. What type of rock should occur in part of the rock cycle labeled H? And under heat and pressure, we know those are going to be metamorphic rocks. And again, it's just, we're going right back to this one here. And let's see, where are we at? Number 11, density. This is pretty much a review question for earlier in the year. We also did a lab on this. Density is mass divided by volume, and again is grams per centimeters cubed. Excuse me. This one you can almost do in your head. 41.2 divided by 8.2. 40 divided by 8 is approximately 5. So you know you had to be somewhere around 5 grams per centimeters cubed. You are hiking a Bright Angel Trail. You see many examples of sedimentary rocks. Describe the processes: weathering, erosion, deposition, compaction, cementation. And those are the processes that form sedimentary rocks. As you are hiking the Cascade Canyon Trail in Tetons, you notice a rock with 2 different crystal sizes. Well, that's going to be porphyritic. Give a possible explanation for how this rock is formed. Well, you know it's going to be igneous, and you're going to have heat, pressure, melting. You could also go the large crystals were small when it was intrusive, and the small crystals were formed when it was intrusive. And we didn't have to do that one there. So this is a review of this. If you're going to do the retest, same format. Again, I didn't ask for any specific rock types. I would again review the lectures and the information on the data sheet. So we'll go from there, and we'll see you in class.